So in my notes, if you remember, I renamed, this section polynomials, and I'm going to build off of this stuff that we talked about yesterday. We were graphing and we were talking about end behavior. So with the end behavior, this, as x goes to infinity, f of x goes up. Well, think of as x goes to infinity, that means moving to the right. As we move to the right, we end up in the first quadrant because we are going up. So f of x is going up. And as x goes to negative infinity, that's moving to the left. We end up in the second quadrant. So f of x is going up also into the second quadrant. And in the next example, we had, as we were going to the right, we ended up in the fourth quadrant or down at negative infinity. So that's indicated here. And then as we move to the left, we ended up in the second quadrant. Okay, so we really focused on the ends of the polynomials. Okay, we talked about the degree and the leading coefficient, kind of like what we were just talking about with our class kick. Okay, if the leading coefficient is an odd number, if the leading coefficient, is a negative number, that means that the right side of the graph goes downward. And if the leading coefficient is a positive number, then the right side of the graph goes upward. All right, so we talked about end behavior, but now I want to focus more on like what happens close to the origin. That's where we find the roots of the function, okay? So if we wanted to graph a function by the roots, and first, if we're talking about just how many roots the function has, this one has 1, 2, 3, 4. It has 5 roots. Those are graphically the x-intercepts. All right, so what we're going to do here today is we are going to graph the polynomial We'll start off graphing by roots. So I'm just going to give you a couple of roots, and we're going to draw some possible scenarios. So let's say we wanted to graph a polynomial that had roots of -2, 0, and 4. Okay, there are a million, in fact, an infinite amount of different possibilities. So we'll just draw a couple. Okay. The first thing we need to realize, though, is that these are the roots, which are the x-intercepts. So I'm going to have an x-intercept here at -2, an x-intercept here at 0, and an x-intercept here at +4. So as long as I have those x-intercepts, my graph could look many different ways. Now, it might look something like that, and I'm going to erase this, so you might not want to draw all these. It might look something like this. Now, if it does, I not only know the roots, but I know something about the end behavior. I know that it would have to be an odd degree polynomial. Odd because they're going in different directions. And I would know that the leading coefficient has to be positive because it is going up as it goes to the right. Okay, so that's one possibility for that graph. The graph might start down here and look like that. That also would be an odd degree, but that would have a negative leading coefficient. Maybe the graph comes down here and bounces off of that point and goes through there and goes back up. That would be an even degree because both ends are going in the same direction. They're both going up. And it would have a positive leading coefficient because of what's over here. So the only way we can have an even degree would be is if it bounced off of one of those points. And it can bounce off any point, really. In fact, it can bounce off of that middle point there and go downward. So I'm just going to leave it at that because that would be an even degree polynomial and a negative leading coefficient. All right, so if I gave you another graph, and let's say that graph looks like this. If it had roots at -4, -2, and 1. Okay, so I have roots at -4, -2, and 1. And let's say that that graph looks like that. I want to list some possible equations for this graph. Now remember, I know that 1 is a root. If 1 is a root, that means that x minus 1 is a factor. Kind of like what we were talking about when we were factoring before. If -2 is a root, that means that x plus 2 is a factor. And if -4 is a root, that means that x plus 4 is a factor. So the factors are, again, thinking about, when you solve them, if -4 is a root, x plus 4 is a factor. So this could almost be this. But I did leave a space here, and I'm going to tell you why in a second. Okay, it could be this so far because I know that I have roots at 1, -2, and -4. So that would give me those 3 factors. Also, if we FOILed all this out, I'd have x times x times x. I would have x to the third, which is an odd number. So it's an odd degree, which makes sense because my ends are headed in different directions. The only thing that I'm missing is going to the right, that one goes downward. So I know that I have to have a negative leading coefficient. And so my number out front would have to be negative, and I'm not going to write anything specific. I'll just make it -4. I just made that up. It could be -10 or -1/2. I do know it has to be negative, though. Next class, I'll teach you how to find that exact number. But that is a possible equation for that graph. So we want to, again, try and be able to, determine the polynomial or the function for the polynomial from the graph and from the roots on the graph. So let's do another one. Oops, I probably should scale that, huh? So I'm going to scale that. So let's say that has a root at -1 and a root at +1 and +2. All right, so this is going to be up here. It's going to pass through there, but it's going to bounce off of here. So I had it bounce at -1. So be careful when you're drawing your graph. I'll give you a second to do that. So I have 3 roots. And I want to try and write a possible equation of this polynomial. Because I have a root at 2, I know that x minus 2 is a factor. And because I have a root at 1, I know that x minus 1 is a factor. And I have a root at -1, so I know that x plus 1 is a factor. But I see a little bit of a problem here. If I multiply x times x times x, that's x to the third, which is an odd number, which means my ends should be headed in different directions, but they're not. So I have to have an even function. Here's how that happens. All right, so don't miss this, because this is a big one that can drive you crazy if you don't get this point. When your function bounces off of a root, that will then make an even degree for the factor. So like this is x plus 1 coming from that root, but because it bounced, we would write that as x plus 1 squared. This one was to the first power because it passed through that. This was to the first power because it passed through that. But because this bounced, I made that x plus 1 squared. And now it works out that I have an even degree because I have x squared times x, which means it's x to the fourth, and 4 is an even number, of course. I also would need a positive leading coefficient, so I could just leave it like this, and that would be fine. Or I could put any positive number in front of here, and that also would be a positive, a possible equation. Yeah.
So wait, how do you know if it's positive or negative again?
How do I know if this is positive or negative?
Yeah.
Yeah, it depends on the right part of the function. If the right part of the function is going up, it's positive, and if it's going down, it's negative. So in our first example, the right side was going down, therefore we needed a negative number out there. And here the right side is going up, so we needed a positive number there. Okay?
Okay, thank you.
Yeah.
Wait, but why'd you put a
fraction?
Number? Yeah.
Why did I put a fraction? It could be any positive number. So for right now, we're not concerned about what that specific number is. We're going to actually do that in our next class to be able to find that exact number. It could be a fraction. It could be, we could change that to be +3. That would also work. So any positive number. Okay, and we'll talk about how to find that specific number in our next class. But for right now, if we just know what the roots are, and also this was a new wrinkle that was squared. All right, so let's try one more. So if we had, let's say a graph, and let's have a root at -1. How about a root at 0? Let's just have those two roots, -1 and 0. That sounds good. And it's going to come down here, pass through 0. It's going to go up to -1, but bounce off -1 and head downward. So our graph looks like that's supposed to go through 0. Sorry, that's a really bad picture. But some things that I know about this graph, I know that it has to be an odd degree because the ends are going in different directions. I know that the leading coefficient has to be a positive number because it's going up as it goes to the right. I know that it has a root of 0. So one of my factors will be x plus 0, which we could just write as x. And I know it has a root at -1, so x plus 1 is one of my factors. But because it bounced there, I'm going to write that as x plus 1 squared. And so I could write it as f of x equals some positive number. So I'll just make up a positive number. I'm going to do a fraction again this time, but remember, it could be any positive number. So 3/5 times the quantity x plus 1 squared times x. The x plus 1 squared came from here. and the X came from here. And that would be perfectly fine. It would normally probably be written this way, 3/5. A lot of times the X, if it's just an X by itself, it's written out front. Those two things mean the exact same thing. All right, any other questions? Okay, I'm going to do a little calculator stuff with you guys. So I'm going to graph a function. So let's go to our graphing calculator because I'm going to graph a polynomial and then show you on your calculator how you could find a minimum or how you can find a root on your calculator. And we did do this before, but this just takes some practice for us to remember how to do that. So I'll do it on the graphing calculator on my iPad. And if you want me to do the handheld, I could do that also. So I'm going to hit new, and I want a new graph. And here is going to be our function. So our function is negative 7x to the 5th plus 2x to the 3rd minus 5x squared plus 1. All right, I'm not going to hit enter yet because I want to talk about that before I hit enter. But it's negative 7x to the 5th plus 2x to the 3rd minus 5x squared plus 1. So some things that I would be anticipating. I know that it is an odd degree because x to the 5th is the highest. It's an odd degree. Because it's odd, the ends have to go in different directions. So I got that in my head. I know that the leading coefficient is negative, so it's negative 7x to the 5th. So I know that going to the right, it has to go down. So those are two things I know already about the function. The right side of it is going to be going downward, which the left side then is going to be going upward because they have to be going in opposite directions. So if I hit enter, all right, that's making sense with me. So that looks like what I expected. Now, the roots are important points. So I can use my calculator to find the roots. So to do that, remember in the upper left corner, there's this tool and the analyze graph function. So in that list, it says analyze graph. You can use that for a lot of different things. But to analyze graph, we can find the 0. And to find the 0, it gives me this line. And I move it to the left of that intercept. And then I'll move it to the right of that intercept. And so it gave me that 0, negative 0.935.
What did you click?
Yeah, I'll do it again because I'm going to find the next 0. So in the upper left corner, you hit the toolbar. And then I'm going to back up here so I have the regular list. I'm going to go to Analyze Graph.
Okay.
And I'm going to find the 0. And then I have to go to the left of it and let go and go to the right of it. And it gave me, the next one. And this actually has 3 roots. So I'm going to find the 3rd root also. So there we go. I could use my calculator to find those roots.
Nothing showed up on mine. I don't know if I'm doing it wrong, but.
Okay, so did you go to, you went to here?
Yeah.
Okay, and you got to 0?
Yes.
Do you have the green line here?
No.
No, that green line didn't come up?
No, it didn't.
Okay, why don't we wait till we're done here? And when we're done, I'll go with you individually and I'll walk you through it. There's probably just we need to turn on, okay? All right, so I also, the mins and maxes are also things that might be interesting. So I'm going to hit the same thing. I want to go to the analyze graph, but now I can find the minimum of the function. It has a local min right here. So that is the local minimum. I can spread this out a little bit so you guys can see that. And I can find the local max as well. Oops, that didn't work. Got to get rid of that guy. Local max. I'm going to let go.
So this is kind of just summarizing what you're saying, but to find the x-intercepts, you use zeros. You like hit 0 and then use the drag thing.
Yep.
And then to find maximum and minimum, you hit that and then drag.
Perfect. You got it.
Okay.
Jen. Yep. All right. So this is just a way of doing what we were just doing by hand using your calculator, which is nice when we have crazy numbers. I mean, it purposely made up, some of these crazy numbers here. Obviously, you'd want your calculator to do that. If we're doing it by hand, you're going to get some nice integer values. Okay. Any questions? All right. Awesome.